Hello everyone, it's Satte Games. In this tutorial, I will show you how you can create a third-person controller with Defold. At the end of the tutorial, you will have this game where our player can move around in 8 direction. We can move the camera, we can run, change the animation speed, switch between animations, and interact with objects. For this, I have used the project from the model import tutorial. So to start, you will need to have your character and the animations ready. If you don't have it, you can go on and watch the tutorial, then continue with this one. First, to create the character collection, I will right click and create a new folder and name it player. On the player, right click, new collection, and name it player. At first, you will have an empty collection. On the collection, right click, add game object, and name it body. Let's focus on the body. On the body, we will have the model, the collision object, and the script. First, let's add the model. You can just add the model here too, but it causes some problems when we use the script to move the player around. So we will first add a game object. You can press Shift A to add a new game object to the body game object and name it model parent. On the model parent, right click, add component, select model. On the model, we will need to get our player ready. So select the mesh you have imported, select the skeleton, the animations, select the textures you have. You should already have the model ready if you have followed the model import tutorial. So I will not go into details. After that, we will need a collision object. So on the body, right click, add component, select collision object. On the collision object, if you press A, you will see the options and select the capsule. Click on the capsule, you can set the diameter and the height. I have set them to 2. We also have a player controller script, which I will explain in a bit. But before that, let's also create the camera game object. So right click, add game object, name it camera, right click, add component, and select camera component. Then we also have our camera controller scripts. So we will need 2 scripts. On the player, right click, new script. Let's name the first one as camera controller. After you are done, click on create script and you will have an empty script. If we go back to the game, you will see that my mouse is locked. You can't see it till I press escape. To be able to achieve this, we will also need a module, which is the pointer module. So on the main or in a folder, we can take this to the player 2. Then we would need to change this to player, I think. We will use this pointer module. I have taken this from the default forum, I believe. And this basically allows you to lock the mouse. I will not go into details of this module. It's not mine. We will be accessing the functions from here, like update lock state from the camera controller. On the controller, we first will create a bunch of game object properties. First property is zoom. It is set to 20. Zoom speed is 0.1. This is how fast you are going to zoom in and out. I haven't shown it, I believe, but you can zoom in and out too. It works. There is rotation speed. This is when you move the mouse around, how fast it is going to rotate around the player. The offset will be used to focus on right above the player's head. If you don't add the offset, you will focus on the feet of the player because when you click on the collection or the body, you will see that the focus is on the feet. Lastly, we have our player ID property. This will be the link to our player body. So camera can rotate around the body. Then we first create a local variable named pointer. This is for the pointer module. We will require it. We have 4 variables: minimum x rotation and maximum x rotation. So this limits the vertical rotation around the player. We can't go into the ground thanks to these limits. We have a minimum and maximum zoom. You can change these values and experiment with them as you like. On the init function, we first acquire input focus, so camera will be able to detect mouse inputs. We initialize some variables: y rotation, x rotation, and zoom offset. We continue and create a bunch of new variables and set them as the ones we have created above. We will use them on the update. We first set the pointer.log to false and self.request log to true. That means the game starts as mouse is not logged, but we want it to be logged, so we will request it. On the update, we first update the log state on the pointer module, and we check if on the module we are not logged, but we want to be logged. Then we use window.setMouseLog to true. Now here we have a bunch of mathematical calculations. As you can see, we have the current y location, and we use lerp from the vector math to make it approach to the y rotation smoothly. Lerp allows smooth transition between values. If you decrease this value and try the game, you will see that camera follows even slower. So it's a nice effect. The higher this value is, the faster lerping ends. What we basically do is we change the y rotation and x rotation on the on input using the mouse input, and we use the lerp on the current versions of them to have a smooth effect. After we have rotations, we can't use them directly. We first convert them into radians, then we use quaternion rotation to turn them into a version we can use directly on the script. We multiply them to get the camera rotation. Now we have the camera rotation. We create a local variable for target position. This is the position camera will focus on, the point that is 1 unit above the player thanks to the offset. This is the position of body, which is here. And if you add 3 units somewhere around here, I think, and the camera will focus there. We create a zoom vector, and then we rotate the zoom vector by the camera rotation. And this basically is a vector from the head of the player to where the camera is. So if you add the target position to the rotated vector, you will get the position where camera need to be at. On the end of the update, we set the position of camera with GameObject.setPosition and camera rotation with the GameObject.setRotation. On input is called when we press a key or move the mouse. So if the action ID is escape, which I have set them here. So if we press escape and action is just released, if yes, then we set the request log to false because we want to unlock the mouse. We set the locked variable on the pointer module to false, and we use window.setMouseLog to false to unlock the mouse. Then we return true or just return, doesn't matter. Now if we use left click and we just released or pressed, doesn't matter, and the pointer is not locked, that means we have pressed the escape before, so we want to log in again. So we set the request log to true, and on the update we will lock the mouse again. Now if we are locked and the action has x and y values, that means this is a mouse input because keys don't have x or y values. Then we set the y rotation and decrease it by dx time rotation speed. If you change this minus to a plus and try it, this will basically be inverted movements. So we decrease the dx from the y rotation and add the dy to the x rotation with the rotation speed. Since the y rotation is looking right and left, we don't need to limit it. But with the x rotation, we need to limit it. And this ensures that the x rotation will stay between these two values. Now, if the action ID is wheel up, then we will decrease the zoom offset, because when you wheel up, you zoom in, and the reverse of it is on the wheel down, we zoom out, so we add the new zoom value multiplied with zoom speed to the zoom offset, and we use math.max and min to make sure we stay in the correct zoom values. Now we are done with the camera controller, and we can see the player controller. To create it, you can right click, new script, name it player controller. After you create the scripts, you can open the body game object, right click, add component file, and select the player controller, and on the camera, right click, add component file, and select the camera controller. On the player, we have a bunch of variables. The first one is move speed, how fast player will walk. Jump force is the force applied to the player when you press the jump key. Raycast length will be used to detect the ground. We have some ground groups, and we will be able to stand on them. As you can see, I can stand on the boxes, but if I delete the default group here, which are the group of the boxes, as you can see, I won't be able to stand on them because the player will think he is still falling down and not on the ground. It should be on. You can add as many groups here as you want. You can add an enemy group if you want the player to be able to stand on enemies. We have some keys for movement. We have a left shift to run and space to jump. We have our direction object, which is the camera, because when moving, player will focus on where camera is pointing at. We have a rotation smooth speed. Player smoothly rotates towards where he needs to go. For example, if you move and turn to the right or another direction, player will smoothly rotate towards that direction, and this is how fast it is going to be. We also have a debug draw variable, which I used to debug when I was preparing for the tutorial, but now we don't use it. We have a bunch of variables. First one is grounded. Grounded will be true when the raycast hits to the ground and player will not play the jump animation. We have a jump timer. We have a table named raycast groups, and we will put the default and the ground groups on this table. We have the last animation. We have two props. The first one is play props, and it basically is the properties you will use with the animation. Playback rate is how fast it is going to be played. 1 means the normal speed, and on the fast we have playback rate as 1.8. So the animation is played faster when player is running. The planned duration is the time that takes switching between animation, and it creates a smooth transition. We have a current rotation, current props, and last played props. I will start with the get raycast groups. This function checks if on the groups we have specified a name. If you leave them as empty, then they will not be included in the raycast groups table. We also have a play animation function. It takes two variables. One is name, the name of the animation we will play, and the second one is mode. We will use mode to specify if an animation is looped or not. If we set the mode as loop when playing, we will use the loop forward, and if it is not, before playing the animation, we need to check if the animation actually needs to be played. For example, if the animation you want to play is the same as the last animation, which is the animation being played right now, and also the props are the same, that means you want to play the same animation with the same speed, so there is no need to play the animation, so we return. But if you don't have the same name, so you are trying to play a different animation, or you are playing the same animation but with a different speed, then we can continue. We create a local variable named props and save the current props on it. We will set the current props on the update function. So if the mode is loop, then we use model.playAnim to play the animation. We enter the URL for the model. For the animation name, we just enter the name. We use GameObject.playback loop forward to set the mode of it. So it will be looped, and we use the props, which can be the play props or play props fast. If it is not looping, then we do the same but use playback once forward. After that, we set the new animation as the last animation. So next time we check, the last animation will be the current animation. And we set the current props to the last play props. On the init function, we first acquire input focus. So a player will be able to detect mouse and key inputs. We create a table named input, and on it we have x and z values. For horizontal movement, we have a jump variable and run variable. Both are set to false. We call the idle animation with loop to start the player at the idle. And for the raycast groups, we use the get raycast group and check if any of the ground groups are empty, and save the groups that are not empty in the raycast groups. We have an isGrounded function. This function checks if the player is on the ground. We create a bunch of variables at first. P is player's position, so we use GameObject.getPosition to get the player's position. We create a y offset variable. When checking for the collisions, we will not check right where player is, because since this point will be touching the ground, sometimes raycast may not work as intended. So what we should do is start raycasting a few units above the player's position, and this is the y offset. We will use 0.2 for the y offset. We create a vector named down, and it will be pointing down by the raycast length amount, which was 0.35. And since we start with a 0.2 offset, the raycast length below the player will be 0.15. So if the ground is more than 0.5 units away from the player, then the grounded variable will be set to false. We create a hit variable, set it to false at first. We have a radius variable, and we have an offset table. On the table, we use radius to create 4 new points to check with the raycast. So we will not be only raycasting from the center, because otherwise, if you stand on a box and you are not exactly on it, player would be playing jump idle animation here, because the center of the player isn't on the box actually. But as you can see, if you are far enough, you still get the animation done. So having more points with the radius will allow us to play the correct animation when player is on the edge of an object or the ground. We use a for loop to check all the pairs from the offsets, and here we create two vectors. One is from, and on it we add the offset to the position of the player. And the vector 2 is basically a vector pointing downwards from the from vector. And with the result, we use physics.raycast, and it takes three inputs. The first is from, where it will start from and where it will be pointed towards. Lastly, the groups that needs to be considered as a hit. If we have a result, and this checks if the surface we have detected is a flat surface we can stand on, then we set the hit to true and break. If none of the offset pairs returns as true here, we return hit, which was set to false at first, so we return false. Now we only have two functions, update and the on input. Let's first check the on input. On input, we check for the actions. If we press the key forward, then on the input, we set the Z value, which corresponds to forward. If it is released, we set it to false. Otherwise, it is set to -1. We do the same for the backward. We set the Z value to 0 or 1. Same with the left and right. We use X value here. We have a key run for running. We basically do the same. If it is released, then we set it to false. If it is not released, then we set it to true because we are running. Lastly, we have the key jump. If we press the jump key, which is space, and we are on the ground, then we set the jump input to true when we press it. Now we only have the update function. We handle a bunch of things on the update. You can copy them and save them as separate functions and call them on the update. That also works, but since the logic isn't too complicated, I just left them on the update. We first update the grounded variable, and we call the isGrounded with self, so it will use 5 raycasts to check if player is on ground. Then we create a velocity variable and use GameObject.get to get the linear velocity from the collision object. Our collision object is set to dynamic, so we will be using built-in physics. If we are grounded, this is a safety check I have added when developing the tutorial. I'm not sure if it is still needed, but it can stay. Now the important part is here. If your jump input is true, that means you have pressed jump, and the jump timer is less than or equal to 0, that means we can jump. We use the jump timer here because, as I have said before, below the player we have a raycast with the length of 0.15, and if you keep pressing the jump key, this grounded variable will be true till the raycast stops hitting the ground, and this part will be called a few times. Instead, we create a jump timer, and when we jump, we set it to 0.2. So on the next frame, when we are still grounded, since the jump timer will be greater than 0, we will not be jumping. And here we decrease the jump timer by delta to reach back to 0, so we can jump again. Basically, this says you cannot jump before 0.2 seconds. When jumping, we set the y velocity to the jump force. Then we set the jump input to false, so it will not be triggered again. If you don't do this and it stays as true, if you jump once, next time you are on the ground, you will continue jumping. We don't want this, so set it back to false. We also play the jump animation once. This was the jump logic. Now we have the movement logic. We create x and z variables and get the x and z from the input. We have that on the onInput function. We use them to create a direction vector, and if the direction vector's length is greater than 0, we normalize it. This is the generic movement logic. If the length squared of the direction is greater than 0, length squared is a less costly function than length because it doesn't take the square root of the vector. So instead of the length, I use length squared. And if it is greater than 0, that means we want to move. So we first get the Y rotation from the camera to know where camera is pointing at. For this, we use GameObject.get on the direction object, which was the camera here. We get the Euler.y. We turn it to quaternion rotation using vmet.quaternion rotation y. Lastly, we rotate the direction using the camera quaternion. We create a multiply variable which starts as 1. And if the run input is pressed, we set the multiply as 3. If not, it will stay as 1. And when we calculate the speed, since we multiply our move speed, which was set at first by the multiply variable, when running, you will move 3 times faster. And if you are running, we set the current props to play props fast. So animations will be played faster, and if not, the current props will stay as play props. Vel is the velocity. We set its x and z value using the direction x times speed and direction z times speed. After we set the velocity, on default, collision objects may be put into a sleep state. So we use physics.wakeup to wake up the collision object because we are about to set the velocity on it. So we wake it up. If the length of the direction isn't greater than 0, that means we are not moving. So we set the velocity x and z values to 0. After that, we use GameObject.set on the collision object and set the linear velocity to the val vector. We have two more things. One is the smooth rotation and the lastly animation. If the length of our direction is greater than 0, that means we have moved. So we probably need to rotate the model parent. We are rotating this game object on the Y. We create an angle variable using 8 and 2 with the directions x and z values. We create a target quaternion using the angle. This t variable will decide how smooth will the character be. When rotating, we set it to rotation smooth speed times the delta, but we also use math.min with 1 because if the game is too laggy, this value may be greater than 1 for extreme cases, and so we set it to at most 1. We use vector math with spherical lerp to lerp the value from the current rotation to the target rotation with the t speed. And lastly, we use GameObject.set rotation on the model parent and set it to the current rotation. This ensures a smooth rotation towards the direction player is moving. Lastly, we have animation. This is a straightforward approach. If not grounded, we will be playing jump idle with the loop. If we are grounded and the length of the direction is greater than 0, that means we need to move. So we use run animation with the loop. There is also this part. You may wonder why we need this. Let me show you. If I run and jump, as you can see, for a split second, Animation switch happens too fast, but if we add this, it will not happen. And the reason for this to happen when you don't have the jump timer check is because after you jump, the 0.15 length of the raycast will still be touching the ground, and the game will think you are grounded and try to play the run animation because you are also pressing the movement keys. But with this, you are telling the game, do not play the run animation if we have just started the jump cycle. If you are not grounded, not moving, then that means you want to play the idle animation, so we play the idle. Now on the main collection, if you right click, add a collection file, you will be able to add the player collection. I didn't create the player as a game object because if you create a game object example, you cannot add new game objects. To it, you can only add components, but we want to be able to add game objects because camera needs its game object, model needs its game object, etc. And we have the ground. I will press F to focus on it. I will press Control and use left click to rotate the world. For the ground, I have pressed A, added a game object, name it ground. On it, right click, add component, select model. On the model, select the built-in cube mesh. If you have followed the model import tutorial or when creating the project used basic 3D project, then you will have this cube, quad, and sphere. Select the cube. On the material, you can select the model material, and for the texture, select any image you have. I have added a new collision object, set it to static, and on the collision object, add shape and box. I have set the dimensions of it to 100, and for the model, I have set the scale as 200 to 200. At first, it will be at 0, but you cannot see the light on the 0, so I have moved it to -20 to be able to see things properly. I will not show you how to manipulate the lights on the scene. It will be the topic of another tutorial. But all you need to do is to create the game object, add the collision object, set the size. On the collision object, set the type to static. It will be on the ground group. It will be colliding with default and player. Our player's collision object is on the player group and it collides with default and ground. I have also added two boxes to be able to test player interaction with collision objects. So I have added another game object, added a collision object to it, set the type as dynamic. It is on the default group and it collides with default, ground, and player. For the model, I have again used the cube, but used a different texture. After that, I have scaled it by 3. Then I have copied and pasted it. This one is scaled by 1. And that's it. That's how you can create a third-person controller with Defold. I will share this project file on my itch.io page. You can find the link in the comment section. You can download it from there. If you have any question, you can ask on the comment section. Thank you for watching and have a nice day.